Arul Somni, working as an assistant professor in Department of IT Department. So here we are going to discuss a topic on how can we use data science to help doctors to predict heart attack risk early in a simple, accurate and clinical explainable way. So this is a problem statement. Now we are going to discuss how we clear this, how we predict the heart attack risk early in a simple and accurate way through a clinically explainable way. So now our students will discuss what are all the points are noted here.
So as per the topic, we are going to discuss in a design thinking base. So first is empathize, define, ideate, prototype and test. So let me explain about the empathize, the stakeholders. So the doctors are afraid, so they might, the AI might take over the jobs, and the patients are anxious because they don't know. They will they will just think it as a chest pain on the earlier stages, and the data science team they have to analyze it using improve on earlier directions, reduce risks, and hospital management thinks that it wastes cost or it improves the time. The insights from empathy interviews. So the doctors are mostly afraid of it, so they didn't want AI to diagnose it. The patients get easily know about the earlier stage heart attacks, and the data science team uses large EHR data, ECG signals and lifestyle records. And the doctors struggle with high patient load, so this makes it them for easier. So in conclusion, in empathize conclusion, it helps the doctors and patients to understand more earlier stages.
Hello everyone, in this defined part we are going to analyze the problem statement. So how might we help doctors to identifying the heart related disease problems for the patients to understand by using the data science. So the core problems are heart diseases does not have any symptoms, but most of the patients could not identify in their early stages, and doctors are also, it predicates the use of clinical explainability, and the patients are also cannot understand their heart related problems in their early stages. So the next is hospitals has been lacking databases as well as not required for their analysis.
So the proposed design criteria is the machine should be as simple and easy to use for the doctors, and it should be easy to analyze the data and as well as to analyze the patient's health cycle, etc. And the output should be easy to understand, not like as a black box which is used in the aeroplanes. So the next is should be easy to understand and as well as to diagnose the patient's health condition and used to give the medical support for the patients.
Now let's see about the ideate. The main idea revolves around to have a solution for a heart attack risk prediction that should be clinical and accurate with a simple solution. Right now, the AI heart risk prediction system mainly focuses on the historical data of heart risk patients, that collects the data of the patients considering their age, their history of family histories, and their BP levels, their smoking habits and their lifestyle. Based on these details, the AI predicts the risk prediction before the prediction is based on their lifestyle and their smoking habits. Here, the report shows the dashboard of patient with their BP levels and their food habits also. Then the integration of the report will be in the computers of the doctors itself, and no new infrastructure is brought under this idea, and it also can be work on the doctor's computer itself.
So I am here to explain about the prototype for the problem statement of how can we use data science to help doctors predict heart attacks risk early. So I am here to explain about the prototype. So for prototyping, we need a data, certain amounts of data. That data are previously made from the doctors. For example, their age, their temperatures, for the pressures, and the heart rates, heartbeats, and then their previous psychological dates, and if they did any checkups further for any other diseases. To explain about the prototype for the clinical uses. So, for example, I'm going to the hospital and I have a previous records for the heart attacks. So they will do the research that my name and my previous records from the other data other hospitals, and then they upload the data and sets in their database and do the search works. For example, what are the medications he did and what are the medicines he intaken before days, and then they do the research works uh, for the upcoming medications. For that prototype is required, which means it gives certain recommendations that if he uses this medication, or if he uses this kind of operation or any other treatments, he can further develop in the future, and his heart attack or any other diseases can be identified before itself. So that prototype is very mandatory for the any problem statements in this.
So I'm going to explain the testing part. We have shown this prototype to the hospital admins, doctors, patients and hospitals. We have get the feedback from them, and the doctor told that this prototype has to be very transparent and mathematically justified, and also they want to us to add the ECG visualization for the extra communication. And the patient said they want this prototype to be some simple and visualizing prototype, and they want the regional language support, lingual language also. If added, we can able to use the prototype. And hospital admins, they want to use this prototype as a for multi departments, and they also want to implement this cardiac implementing prediction prototype to implement in the multi department part. From the improvements after testing, we have added the multilingual language and the ECG visualization also. This improves the prototype more belongs to the prediction of cardiac patients. Thank you.
So now we are concluding this by so following these steps, we can predict heart attack risk with 92% accuracy, and it saves the doctor's time, and it encourages preventive care, and it enhances doctor-patient communications, and it also reduces emergency cardiac admissions. So here the doctors accepts the tool, like it is transparent and explainable. It fits their workflow, and it assists clinical decision making, and it also improves patient outcomes. So these are the pinpoints. We are conclude this by following these steps. Thank you.